In this video, we're going to discuss how molecules are put together in terms of bonding and why the formulas end up the way they are. A covalent bond is one in which there is a shared pair of electrons between more than one atom, and in this case we are generally going to try to construct molecules so that all of the atoms involved have a total of 8 valence electrons. This will generally form closed valence shells and then produce very stable molecules. As an example, shown below here are 2 individual chlorine atoms. Chlorine would have 7 valence electrons as represented by the dots that you see here. And if we were to bring those 2 chlorine atoms together, sharing the individual unpaired electrons, we can form a so-called diatomic molecule. In this case, then, we would form a bonding pair of electrons, as shown here with the 2 electrons between the 2 atoms. And in addition to that, then, we would rewrite this so that the electrons that are shared are distinguished from the other electrons as a bond. This is then drawn as a line. The line represents the 2 shared pair of electrons, or 2 electrons. The other electrons, which are not involved in bonding, are then referred to as lone pairs, and they are shown here as well. As another example of a diatomic element, you can consider hydrogen. Hydrogen has 1 electron in its outermost shell, its valence shell, but it only needs 2 electrons to complete that shell. So therefore, if we bring together 2 hydrogen atoms, we can then share both of those electrons between the 2 hydrogen atoms to form the single bond, and this is then a very stable situation for hydrogen. This is not the only way one can go about forming the covalent bond. It is possible to start with a molecule that has a lone pair of electrons, as shown here for ammonia, NH3. Notice that there is a non-bonding or lone pair of electrons on the nitrogen, and if we were to combine this with a hydrogen ion, which has no electrons in its outer shell, and then end up sharing the pair of electrons that originally started on the nitrogen, we can then form the so-called ammonium ion, where now we have 4 bonds between nitrogen and the 4 different hydrogen atoms. In some cases, it may be necessary to form more than a single bond. In the example that we just got done considering for hydrogen, there was only a need to share a pair of electrons to complete the shell. However, in the case of other molecules, we may end up sharing more than 1 pair of electrons. So, for example, in the diatomic element oxygen, in order for both atoms to have the so-called octet, it requires that 2 pairs of electrons are shared, and so in this particular case, then we form a double bond. In the case of the element nitrogen, there is a need to form a triple bond to get 8 valence electrons around both of the atoms. So, generally, as the number of pairs of electrons increases, the so-called bond order increases. This creates a greater and greater attractive force between the atoms, and hence the distance between the 2 atoms will decrease when we have higher and higher bond orders. At this point, we want to discuss the naming of molecular compounds, which are generally comprised of all nonmetals in the formula. In general, we will be naming the elements in the order that they appear in the formula from left to right. And in addition to that, we will somehow have to indicate the number of atoms within the formula for each of these elements. So for the first element in the formula, we're going to use that element's name. And then for the second element in the formula, the ending is, or the suffix is changed to the ending of "ide." In addition, then we have to indicate how many of each of both of the elements are present, and this is done using prefixes. These are the same prefixes that we saw previously, the Greek prefixes, so these should be memorized. As an example of how to name a molecular compound, we have a compound here with 4 phosphoruses and 3 sulfurs. To name this, we would start out and ask ourselves, is this an ionic or a molecular compound? Since it contains all nonmetals in the formula, it must be a molecular compound, and so therefore we are going to use our prefix system. So again, we're going to name the first element, and we're going to indicate how many atoms of that first element there are, and then we'll name the second element with the ending of "ide," but then also a prefix to indicate the number of the second element that is present. So in this case, the name is tetraphosphorus trisulfide. Again, the prefix tetra means that there are 4 phosphoruses, and the prefix tri tells us that there are 3 sulfurs, and of course we end it with the suffix "ide" for the sulfur. So for these binary molecular compounds that are comprised of 2 nonmetal atoms, generally the formula will always have the first element be further to the left and down in the periodic table, and so in this case that also increases the metallic character for that particular element. That will be the thing that is then named first, and so there's this general order of the elements that will appear in these formulas. The one exception to this is hydrogen. Hydrogen is normally found way over the top of group 1. However, in this particular case, it's useful to think of it as being somewhere in between nitrogen and oxygen in terms of its metallic properties. And so that then dictates that if you have a compound that has, say, nitrogen and hydrogen in the formula, the nitrogen would come first. Whereas if the compound has oxygen and hydrogen in the formula, then the hydrogen comes first. So for example, water is always H2O, whereas ammonia is always NH3. As another example, in this particular case, we want to consider a compound that has 4 chlorines and 1 silicon atom. So the question is, what is the formula and the name of this compound? In the first question that we would ask is, this is a molecular or ionic compound. Both chlorine and silicon are nonmetals, so therefore it's a molecular compound. And then we have to ask ourselves, of those 2 elements, silicon and chlorine, which one is more metallic? Silicon is further to the left and down than chlorine, so it will be the first element in the formula. And so in this particular case, then the formula of the compound is SiCl4, and the name of the compound would be silicon tetrachloride.